All right, people, this is 2.2 notes intercept form. I could get more specific, probably should have. Graphing in intercept form. Sometimes you will hear this called factored form. I just tell you that in case you try and look this up and you're struggling to find stuff. If you want extra help, sometimes it's called factor form. Like that's what Khan Academy calls it. Anyways, intercept form. We are going to start with the general idea. It's different than vertex form and standard form. So vertex form has the parentheses and the squared. Standard form has no parentheses. Intercept form looks like this. Now it starts off with y equals, just like the others. It starts off with a, just like the others, which means the exact same thing. But intercept form actually has two sets of parentheses. Yep. And then inside those parentheses, it's got two x's, one x in each, and then it's got two different numbers here. Now I'm going to throw some letters down that are just referencing any number that go in here. The letters aren't that important. And what is important is this negative sign that goes in front of them, and typically you'll see P and Q, but again, those letters really are not that important. All right, I'm going to give you an example. I'm going to use number 1 for an example. So number 1 says f of x. Remember, that's the exact same thing as y. And then it says 2x minus 7 and x minus 3. All right, now there's quite a few things I want to show you with this. First, and you're not going to have to do this, but I'm going to show you at one time. I want you to see how I could take this and how I could put it into standard form if I wanted, just so you can see how those two are connected. Assuming that you remember how to take x minus 7 and x minus 3 and multiply them together. If you don't, x minus 7 times x minus 3. If you don't remember how to FOIL, that's okay. I just wanted to show you. First, outside, inside, last is how I would multiply these two things together. So first, x times x is x squared. Outside, x times negative 3 is negative 3x. Inside, negative 7x, or negative 7 times x is negative 7x. And last, negative 7 times negative 3 is positive 21. These two things in the center can combine to make a negative 10x. So x squared minus 10x plus 21. Now that's what you would get if you would multiply these things together. Don't forget we did have a 2 in front. So if I took this 2 and if I distribute it to all three of these things, I would get 2x squared minus 20x plus 42. Now, I just want you to know that this is what this equation would look like if it were in standard form. Now, that's not crazy important, but I want to show you that intercept form is just another form of a quadratic, just like standard form or just like vertex form. All right, now let's go back. Let's look at the instructions for number 1 and talk about the things that you're going to have to find. Sorry, I had to make sure my instructions are right here, because on yours, on number 1, it says graph the equation, identify the vertex, axis of symmetry, and x-intercepts. So we've got 3 different things here. You've got the vertex, you've got the axis of symmetry, you've got the x-intercepts, and then graphing. But these 3 things is what you're going to have to find, just like the last one. I'm not going to take them in that order. I'm actually going to find the intercepts first. Now again, we are looking at f of x equals 2 times, what was this? X minus 7, x minus 3. And we are going to start by finding the intercepts. Now to find the intercepts, here's what you need to do. You set the insides equal to 0. Now I'll show you what that means. Now this is called intercept form because it is super easy to find the intercepts, the x-intercepts more specifically. Just like vertex form, it was really easy to find the vertex. Intercept form, super easy to find the intercepts. So anyways, I'm going to take the stuff on the insides of the parentheses, these two things, and I am going to set it equal to 0. Okay? I'll show you why. Now, x minus 7 equals 0. I'm going to solve. If I add 7 to both sides, that gives me x equals 7. Over here, if I add 3 to both sides, that gives me x equals 3. Those two things are your x-intercepts. Done. Now, if I got more specific, my x-intercepts are 7, 0 and 3, 0. And I'm going to show you why. I'm going to come back up here. 2 times x minus 7 times x minus 3. What would happen if I plugged in x equals 7? Well, it would say 2 times, I'm going to plug in 7 for the x's. This is what it would look like if I plugged in 7, right? Instead of the x's. 2 times, well, 7 minus 3 over here is 4. 7 minus 7 is 0. You know what 2 times 0 times 4 is? It is 0. Now, the reason that 7 works and the reason that we set this equal to 0 is because if one of these things is equal to 0 and you're multiplying, everything will be equal to 0 because 0 times anything is always going to be equal to 0. So what we tried to do is, or what we did is we said, well, what will make this chunk equal to 0? Well, if I plug a 7 in here, 7 minus 7 equals 0, therefore that's going to 0 everything out. And then we went over here and we said, well, 3 minus 3 equals 0, so that's going to 0 everything out. And a quick and easy way to find that, set them equal to 0 and solve. Now I want to show you what if we had plugged in 3. So 2 times both my parentheses, if I plug in 3 instead of my x's. Now notice this time I don't have 0 here because 3 minus 7 is negative 4. But, this should have been a 3 because that's my equation. But here I have 3 minus 3 is 0. So now 2 times negative 4 times 0 still just gives me 0. All right, now I'm going to come down here to number 1, and we are going to talk really quick about what it means to have x-intercepts. X-intercepts are the places on the x-axis where the graph touches. Now we said those two spots were at 7 and 3, meaning I could go to the x-axis and I can put a dot at 7 and I can put a dot at 3. And I know my graph is going to cross those 2 points somehow. I'm not quite sure yet. You could look at the fact that this is positive and say, I know it's going to be flipped up, so it's going to look something like this. Okay? All right, now, so we found the x-intercepts. Done. Let's go to the next thing on here. I'm going to find the axis of symmetry. The axis of symmetry. So f of x equals 2 times x minus 7 times x minus 3. And then we found that our x-intercepts were at 7 and 3. Very important. Now, if you want to find the axis of symmetry, you are going to average your x-intercepts. Average your x-intercepts. Another way of saying that would be to find the middle. Find exactly halfway in between your x-intercepts. Now, I'm going to do that on the graph first. If I come here and I say there's 1, 2, 3, 4 different spaces in between these two points. So if I wanted to find halfway in the middle, well, 4 spaces, cut that in half, 2 spaces. So this right here would be my axis of symmetry, which looks like it has an x value of 5. So my axis of symmetry is x equals 5. Let's see, x equals 7 and 3. These were my x-intercepts. My axis of symmetry is x equals 5 because that's exactly halfway in between. All right, now let me show you that mathematically speaking, because if you're not looking at a graph, some of you are going to be able to look at this and just pretty quickly say halfway in between 7 and 3 is 5, and some of you aren't. That's okay. So here's what you're going to do. For an average, you're going to take your two numbers, 7 plus 3, and then cut them in half. Quick and simple. 7 plus 3 is 10. 10 divided by 2 is 5. So your axis of symmetry, x equals 5. Once you know how to do these things, they go very quickly. Now we're taking our time on this problem, but again, once you know how you do them, not bad at all. Okay? All right, so we found the intercepts, we found the axis of symmetry. The very last thing that we need to do here is we need to find our vertex. And I already told you how to do that there. To find the vertex, plug in the x value into the function and get y. So f of x equals 2 times x minus 7 times x minus 3. Now if we want our vertex, we actually already have the x value. The x value of the vertex, don't forget, is the axis of symmetry. Axis of symmetry. Because that runs exactly down the middle. I know my vertex is going to be somewhere on this line of x equals 5. So if I want to find the y portion, all I have to do is plug 5 in for your x's. So 2 times, and instead of x's, I'm going to plug in 5, and I'm going to see what I'm going to get. Okay? So 2 times, let's see, 5 minus 7 is a negative 2, and then 5 minus 3 is a positive 2. Weirdly, this is actually going to happen every single time, but because you have the exact center being subtracted by these two numbers. Anyways, not crazy important. 2 times negative 2 times positive 2 is a negative 8. That goes in here. So my vertex, in this case, vertex is 5 comma negative 8. And then we could graph that. 5 comma negative 8 right here. Now, in terms of the graphing, especially since we're not in person, I'm not going to get too crazy about graphing. So as long as you have my vertex and you have my x-intercepts, I'm cool with you just kind of connecting them. This is going to be another one of those things where you actually have to draw your graphs. Oh, I'm sorry. Anyways, okay. So, x-intercepts, axis of symmetry, vertex. You're going to want to find them in that order, and then once you graph those 3 points, you can connect them. Done. Cool? All right, now, for these other ones, these are going to go a bit quicker, okay? Because we know what we're doing at this point. So let's look at number 2, and I'm going to find those 3 things first. Okay? So number 2, if I'm looking at for the x-intercepts, all I am going to do is I'm going to take what's on the inside of my equal sign, inside of my parentheses, so x plus 7 and x plus 3, and I'm going to set those equal to 0. Weirdly enough, this is very similar to the last problem. And then I'm going to solve. Now, some of you are going to notice a very quick shortcut. If it's simple like this, you can just take the opposite of whatever you see here. For instance, positive 7 turns into a negative 7. Positive 3 turns into a negative 3. That works too. If there's a number in front of x, that won't work. So I recommend doing this every single time. But anyways, axis of symmetry is next. Now, I have a negative 7 and a negative 3. So if I want to find the axis of symmetry, I'm going to take those two numbers, add them together, and cut it in half. Okay? So a negative 7 and a negative 3 gives me a negative 10. And when I cut that in half, I get a negative 5. Negative 5. So let me write down what I have so far, actually. We found out that my x-intercepts were x equals negative 7 and negative 3. Now notice how I'm writing this. Instead of writing like the points, negative 7 comma 0, negative 3 comma 0, I'm just writing x-intercepts and then this. And that's totally fine. So a negative 7, a negative 3, and then I found my axis of symmetry is at negative 5, going straight through the middle. And then lastly here, we wanted our vertex. Now, vertex, I need my equation, f of x, which equals a negative x plus 7 times x plus 3. And remember, if I want to find the vertex, I already have the x portion. So I'll just write this off to the side. Negative 5 is my x portion, and I just need to take that and plug it in these two spots. So negative, and then instead of my x's, I'm going to write negative 5, and then we're going to see what we come up with. So negative 5 plus 7 is positive 2. Negative 5 plus 3 is negative 2. Negative 2. Write that correctly. Again, notice how these are the same, but one's positive, one's negative. And then I have a negative in front. Let's do this really quick. 2 times negative 2 is negative 4. And then you multiply that by a negative, and you get positive 4. Positive 4. That's the y portion. So I'm going to come back here. I never wrote my axis of symmetry. That was x equals a negative 5. And then we just found my vertex, which was negative 5, comma positive 4. Those are the 3 things you needed to figure out. And then once you graph them, negative 5, 1, 2, 3, 4. So I have those 3 points. You can connect them, and you can call it good. One more thing just to note. This number in front is the a value, right? The a value. And what I told you with standard form and vertex form is the a value is actually from the vertex, the slope to the next point on the right-hand side. So this number in front is negative 1 over 1, down 1, right 1, mirror image on the other side. If you notice that works out. Even if I go over to number 1, the number in front is a2. So if I go from my vertex up 2 over 1, slope of the right-hand side. Just to show you, that's not crazy important. I'm not even going to ask you to graph those dots, but I just want you to know that that number in front, it's called A because it does the exact same thing as vertex form and as standard form. All right, let's come down here to number 3 and do all the same stuff. All right. Let's see if we can do the x-intercepts this time with that little shortcut that we were talking about. Now, this says negative 6 and negative 1. So if I took the opposites of that, it would be positive 6 and positive 1. Hey, look at that. X-intercepts. Boom. Positive 6, positive 1. Okay. All right, I'm going to come back here. So we just found our x-intercepts to be a positive 6 and a positive 1. Now we want our axis of symmetry. Now there's a reason I wrote this down. So if you take those two numbers, add them and cut them in half, just like we said before, average. I'm trying to find exactly the center. 6 plus 1 is 7. 7 divided by 2 is 3.5. Ooh, we're getting a little bit tricky here. You're not always going to have a nice number for this, but that's okay. 3.5, not too crazy, especially in intercept form. It's actually not nearly as bad as if it were vertex form or as if it were standard form. All right, now we're trying to find the vertex. That's the last thing that we need to do here. And this is just x minus 6, x minus 1. Again, for my vertex, we already have the x portion. The only thing we're looking for is the y portion here. So I need to take 3.5, we already figured that out, and I need to plug it in for my x's. I don't know why I switched my colors up here, but we're going to go with it. No number in front this time, and we are plugging in 3.5. Now again, you'll notice here the math is not that bad in intercept form. 3.5 minus 6, you can do that with a calculator, you can do it in your head, is 2.5. And then 3.5 minus 1 is, sorry, this is a negative 2.5. 3.5 minus 6 is negative 2.5. 3.5 minus 1 is positive 2.5. Get it together, Mr. Hayward. Now this one you are probably going to want to do in a calculator. Negative 2.5 times positive 2.5 is negative 6.25. Boom. And don't forget that goes in here, negative 6.25. Now that's kind of ugly, but that's okay. It's fine. All right, let's put what we know on here. Our x-intercept, we found our axis of symmetry was x equals 3.5. So if you wanted to, 3.5, you'll notice the axis of symmetry is not on a perfect spot. It's actually going to be in the middle of a box, but that's okay. And then we found our vertex is 3.5 comma negative 6.25. So I'm going to graph my vertex. So 3.5, I know that's on my axis of symmetry, and then I'm going to go negative 6.25. I am not going to get crazy about where specifically in the box it is, as long as it's kind of in the right box. I don't know why I made that dotted. Then you're good. That's it. We found our x-intercept, our axis of symmetry, and our vertex. Let's do one more, and then we can finish up this video. All right, let's see if we can do some of this a little quicker than we did for the last ones. Let's use some of our shortcuts here. All right, so first we are looking for the x-intercepts. X-intercepts, you're looking for things that'll make these two 0. I did not mean to use 7 and 3 so many times here, but I did. Okay, opposite of a negative 7 is a positive 7, and opposite of a negative 3 is a positive 3. Boom, done. X-intercepts. Now, our axis of symmetry here, take these two numbers and you're going to average them. They're the same numbers as number 1, but we could do it again. Axis of symmetry, so 7 plus 3 is 10. 10 cut in half is 5. So our axis of symmetry is 5. Now let me put down what we have so far. We have dot at 7, dot at 3. Again, shouldn't have used those numbers so much, but I did. And then I know I have an axis of symmetry down the middle, which is x equals 5. All right, the last part is our vertex. And I know the x portion of the vertex is 5. So really the only thing we're looking for is the y part of the vertex. So I'm trying to take that 5 and I'm going to plug it in for those two x's. So negative, and then I'm going to plug in 5 for my two x's because that's my axis of symmetry. 5 minus 7 is a negative 2. 5 minus 3 is a positive 2. So just like before, actually negative 2 times positive 2 is a negative 4. Times this negative, you get a positive 4. So the y portion of my vertex is 4. So I'm going to plot that, 5, 1, 2, 3, 4. And then I'm going to connect these. Now this should make sense because we have a negative number in front, meaning I knew it was going to flip down. Okay. X-intercepts, axis of symmetry, vertex. Really quick recap. If you want to find the x-intercepts, you're just going to take the nonsense on the inside, set it equal to 0. When you want to find the axis of symmetry, you're going to take your x-intercepts and you're going to average them. You're going to find the middle, add them up, cut it in half. And then lastly, to find your vertex, you're going to take that x value, your axis of symmetry, and you are going to plug it in to both x's to find y. That's it.